Welcome to the Geek Compound. Where's my food?
Slashdot kind of grew out of my personal homepage. At some point, about 2 years ago or so, I had a page where I just kind of put a page rant, you know, or I'd read a couple paragraphs. Here's this neat web page I found, you know, and here's this cool Linux program I compiled and played with and hacked this too, yada, yada, yada.
I think in the next 2 or 3 years you're going to see a significant shift towards online distribution of music. It's just so much more convenient for the consumer, and it's so much cheaper and so much more cost effective. I think that Linux is going to be a big part of that, because both from the end user side, you know, we're already starting to see some custom Linux hardware applications to play MP3s, and then also on the back end it's been very instrumental for us in distributing the content to the consumer.
Our network consists of over 900 servers located in 65 places in 15 countries around the world. And the key idea behind our service is that when a client goes to one of our content provider sites, they'll receive the original HTML documents from the content provider, but then all of the large sites, so all of the large objects that would consume bandwidth at the content provider site are served instead by us from the optimal server for the client, and that typically means a server on the same network nearby to the client.
Basically, I'm involved in 2 projects. One is a project which is actually based on experiments being conducted here at Brookhaven. These are the RIC projects, where RIC is the relativistic heavy ion collider.
Linux provides the scientists the capability of moving from laboratory to laboratory and not having to learn the local operating system that exists at that particular site.
eToys began about 2 years ago and is solely focused on web selling for kids. I think Unix today obviously offers a lot of scalability and availability type of software solutions, and those things are quickly becoming available on Linux. eToys is a very early user of Linux and works closely with a lot of software vendors and is aware of their plans to continue to provide more availability.
We've discovered that we have this full-blown Unix-like operating system that runs in full blast 32-bit mode, full, you know, multi-user operating system, and really brings out all the power that Intel architecture had. Was a real revelation to us, and we started quickly doing benchmarks on it to see how well it would perform.
That calculation that took 3 months, that became one of our benchmarks. I mean, we didn't run the whole calculation, we ran part of it. But we then first improved the code, and by improving the code, we got that down to a month. On a quad Intel system, we now have running in parallel, the Portland Group compiler, Linux. We have that down to 40 hours.
Decoding the genome requires enormous computing power. We've used Linux in our operating systems here to be able to do large amounts of data processing in a very cost-effective environment. We've been using it for over a year now at Insight in a commercial, robust system in real time, supplying data to our pharmaceutical partners, and have been tremendously impressed with both the robustness of the system and with the support of the Linux community in us being able to carry out our work.
So long, farewell, auf Wiedersehen, adieu, 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 to you and you and you.
Ladies and gentlemen, Sean Maloney.
Well, good morning, everybody. As the Slashdot guys say farewell, adieu, I say good morning and welcome to LinuxWorld. Actually, we like the idea of closing with that clip because it was such a kind of funny clip. It was difficult then to give a very stiff, formal technology presentation. And what we wanted to do today was to have a bit of fun. And we've actually laid out the stage. It's a bit like a sort of game show thing. And behind each one of these doors we've got a technology demonstration, and we've got some pretty exciting stuff here. And I want to start by saying a big thank you to Larry Augustin and the VA guys who've given us a lot of help over the last few weeks. So many of those companies that you saw there in that opening video, all of the applications are accessed across the net. And some of those companies have actually started or developed to take advantage of the internet economy. And I'm going to spend most of the time here looking at technology demonstrations on how we address the challenges of the internet and how we go about making the computer systems more robust and reliable and so on. But I want to start by doing a little tour back over the microprocessor on a march or a path towards what we call free MIPS. And that's kind of free in quotes. And the idea came from back in the early 1990s when we were looking at the kind of avalanches of processing power that carried on building up wave after wave every year. And Andy Grove, who was then our CEO, came up with this idea that there was a fundamental relationship between processing power and communications bandwidth. And as that more and more and more MIPS flooded out around the world, they would inevitably suck in more and more communications power, and you'd have a reduction in communications costs, and somewhere these kind of free, very low-cost MIPS would collide with very low-cost communications. Now, a few years later, you look back on it, and as a computer person, you kind of complain that communications costs haven't come down as fast as we would like. But if you look on the processor side, I think there has been pretty considerable progress towards massive, massive, massive reductions. The story obviously started back with the 4004, which was in the early 1970s, the world's first microprocessor. All through the 70s, a series of iterations, the 8085, the 8086, the 8088. By the time I joined Intel back in '82, we were onto the 286. The 286 had got some inbuilt memory management features, and so there started to get some early ports of Unix operating systems like Xenix running on it. And I actually joined Intel as a software guy working on Unix on the 286. And this was an incredibly damaging start to your career. I've forever been left with the delusion late at night that I can get more done in VI on a line prompt than I can with any piece of software ever written afterwards. But we were kind of hanging out for what seemed like a long period of time for a good 32-bit engine, Intel 32-bit engine. That, of course, came along with the 386 in 1985. And the 386, of course, was used by Linus in the early 1990s in his original work on Linux. Subsequently, the Pentium processor came along in 1994. That was pretty much the year that there was the whole multimedia boom. The volumes in the computer industry the PC industry began to get very, very large. And we're now in a situation where we're exceeding, the 100, 120 million units a year. That Pentium era was the multimedia era. And what we're seeing now with the Pentium 3 is just tens, hundreds of millions of people coming onto the internet and primarily using the PC to do it. Now, Gordon Moore, who was one of the founders of Intel, has been playing with the idea of looking at what's happening with all these transistors. And the PC has sucked along behind it this huge industry producing transistors for memory and so on and so on and so on. And actually, if you look at it, the transistor, which is very much a post-war development within 30 miles of where we're standing here, has gone from being in extremely low numbers up to around a cumulative total of something like 10 to the 17 transistors shipped. Now, just to get that in some context, Gordon wanted to give it some context, so he decided the one thing that there are a lot of in the world is ants. Now, I don't know how he calculated the number of ants, but he's pretty precise on his numbers. And anyway, 10 to the 16 is apparently the number of ants there are. So for every ant, there are now 10 transistors. And that gap is actually increasing because transistors breed faster than ants. Now, the other way of looking at it, of course, is the way the price has been coming down, and the discrete transistor, which started off in the dollar and multiple of dollars, is now down somewhere between the microcent and the millicent. So, incredible amount, more and more transistors being squeezed into a smaller, smaller space, more and more processing power, and you end up with a phenomenon that if we were to stop the clock now and look again in 12 to 15 months' time, between now and 12 to 15 months' time, the amount of processing power we ship will be more than the entire total number of MIPS since the development of the computer at the end of the Second World War. And you can make that observation at any point looking forward over the next 12 to 15 months. So in a sense, there has been progress towards free MIPS. That first Unix machine that I worked on, microprocessor-based Unix machine, was about $5,000, and it performed at about half a MIP. And now if you add up a fully loaded PC with a Pentium 3, 500, 550, it comes down to about $1.50 or $2 per MIP. So there has been huge progress towards free MIPS. Though, of course, I do say free, as many as you will point out, not open. Okay, but life isn't about what have you done for me so far, it's about what are you going to do for me now. So Intel is basically a manufacturing and technology company, and so we took the camera into our advanced lithography labs and our extreme ultraviolet labs and went around and asked a few of the engineers there what excites them and what they're working on to keep this thing pushed out through another 3 generations or so. And we're going to start with Gordon Moore and some comments of his, and we'll finish with Albert Yu, who is the guy who runs all of our microprocessor development.
Our first microprocessor only required a few engineers about a year to put together. Today, with several million transistors instead of a couple of thousand on the microprocessors, we use extensive computer aids and large teams of engineers, maybe as many as 400 or 500 working on the same product at the same time, spread all over the world.
I'm program director for the EUV LLC, which consists of a consortium of companies led by Intel. We're developing an advanced lithography tool. Lithography is used to transfer circuit images from the drawings to the actual silicon.
What's exciting is that we're building a real product. We're using models to guide the design of something that's going to be built and sold, and the new cutting-edge product in the lithography market.
The engineering test stand is in the design phase right now, and what we're doing is we're doing the thermal and structural modeling that takes the thermal and structural effects and relates it to the final lithographic performance of the tool.
As the chip size gets smaller, we're looking for new tools, and the work we're doing here is pushing out the envelope of what we can do in microelectronics.
What's really exciting to me is the fact that we're using these tools to look at scales on the nanometer scale on a tool that's several meters in size, and that sort of scale and that sort of accuracy is something that hasn't been achieved before.
I know you've seen examples of a semiconductor chip, like a Celeron or a Pentium 2 or 3, packaged as an individual integrated circuit, and that continues. And probably the best example is the mobile product, where smaller is better, and we continue to make them smaller and smaller. The great contrast to that, though, is the integration that we've used inside of today's cartridges applied to a server, a very complex configuration.
We are very aggressively going after key technologies that enable Intel to make faster and smaller transistors. Today, most of the industry is still focusing on 0.25 micron and 0.18 micron transistor technologies. Our team has already successfully fabricated a functional 0.06 micron transistor with oxide thickness of less than 10 angstrom. And it is a very small transistor, and we're actually counting atoms.
Every time we do a microprocessor, we push the frontier on everything, and we've never done any of these things before. But somehow, you know, with really smart, creative, hardworking people, we made it happen. And we do it again, and do it again, and keep on doing it again.
Okay, that's a quick tour around some of the work that's been going on. But I think we're all going to need lots of very smart, energetic, hardworking people, because in many ways, we are sort of at the end of the beginning of the computer industry, in that I think now really the fun really starts with the arrival of the internet. And the challenges that 200, 500, 1 billion users will bring to us are really huge. They dwarf any of the previous challenges that we've faced as an industry. And I think if you look at all of those challenges together and try and kind of sort them out into a list, I think there are a series of things that we need to do. We need to have access anywhere to the internet at an affordable price. We need to have a way of getting through the sensory overload, the vast amount of material and emails that inevitably is going to grow and grow and grow. We need some way of handling that. We need to get instant response and total reliability. And I think those are really the list of things that we need. We never want it to fail. We want to get instantaneous response. We want to get the information we want exactly when we want it and get access anywhere. Now, with the reduction in cost of the PC over the last year, 2 years, 3 years, and the growth of the industry around the world, you are now getting a sort of aftershock of the PC moving into all the other countries outside of the United States, the internet PC. And so within 2 to 3 years, you will have more people on the net in Europe than you have in the United States. And behind that will be the whole of Asia. You also have a move of the PC into things like cars and much more shrunk mobile form factors. Of course, it's not just the PC. You have other kinds of appliances as well. This appliance here, which you may have seen, is a RIM pager. It's an interactive pager, and it uses the IP infrastructure, the internet, to send and receive emails. This thing has a 386 in it, so it has the same processing power as the platform that Linus used to develop Linux. And then, of course, at the same time, you've got the emergence of the internet-connected cell phone. End of '97, there were something like 200 million cell phones in use. Very, very few of those had internet access of any kind, probably zero. By 2002, 2003, the projections are there will be 500 million cell phone users, and most of those cell phones will come with WAP, wireless access protocol, and some kind of internet connectivity. That, of course, tends to increase the problem, the challenges of the second problem, which is sensory overload. And in some ways, with all the content that we have and the number of people coming on sending emails, it's almost like being under siege. I think Intel is a reasonable example. We've deployed email 100% now for several years. And as the whole organization gets wired up and you get that faster and faster beat rate of communicating and competing and informing each other, the numbers of mails goes up and up and up. My inbox is 150, 160 mails a day, and I know many people are up over 200. We obviously need to have better and better server-side and client-side tools to determine what's important and what isn't important. You have the same problem when you go out on the internet looking for content, and you're all familiar with the huge lists of hits that you get when you do simple searches. That problem is only going to move in one direction as Europe and then Asia also starts to generate vast amounts of content. What I'd like to do now is to take a look at some methods of trying to navigate and make sense of all that information. And I want to start with a local company here which uses Linux called Google. And let's take a look at how Google is focused on solving those search problems.
Finding information on the web is a really hard problem. To do the best possible job finding information, you'd have to understand, all the content in the world and, the question that the user was asking.
Google is really focused on search. That's the #1 objective of the company, is to provide the best search experience to our users. Google got started a while ago, and it was mainly Larry Page, who was a co-founder with me. He was interested in the link structure of the web, and he started going out and collecting it using an early version of our web crawler. I, at the same time, was working on data mining at Stanford and running sort of data mining research there. So I looked at what Larry was doing, and it was this very interesting piece of data, which was the link structure of the web. And he interested in me right away, and we've continued to work together since.
So let's take a look at Google, and we should have Randy coming up on stage. Randy Hill. Hi, Randy. How's it going?
Morning, Sean. Doing all right.
All right. So we're going to take a look at Google, and in order to do it, I want to start by doing a couple of searches. We'll start by doing a search on Yahoo.
Okay.
Now, not for one second here am I knocking Yahoo. I think Yahoo's done an absolutely awesome job. My homepage is set to Yahoo, and Jerry Yang and the guys are really, really doing zillions and zillions of wonderful things. But what we want to do here is just look at what happens if you focus just on the search part of it. So, for example, if we wobble onto Yahoo, and let's look at some familiar cultural stuff.
How about the Simpsons?
Absolutely.
Television
Start with
show?
Simpsons. Whoops.
Wait a second. That
You're
was not it.
leaping ahead here. Okay, so we go do a search on The Simpsons, and we get 1,400 products for Simpsons. We get 801 sites for The Simpsons, and so on and so on and so on. So, information overload. Let's give it a try on
Google?
Google.
Okay.
Now, all of that information we saw there is really, really wonderful information, but let's give it a try.
Okay, so if we were to click on the Google search, it would act a lot like how Yahoo came up, but if you click on I'm feeling lucky, it's going to pick the most relevant one and bring it right up. And so this is the Simpsons index page, which brings you one click away from...
Right, you're right where you're right into The Simpsons. Okay, and there's a Shockwave running on top of Linux. So now let's think about a more recent but kind of bizarre cultural reference.
Well, next to Star Wars, I think that would be like something like Austin Powers.
Austin Powers, the most hyped movie of the summer.
So, and let's not make it easy. Let's do something complicated, like just a reference, like Yeah Baby or something like that.
All right.
Okay.
Let's give it a Yeah Baby.
And click on I'm feeling lucky, and it brings you right there.
You go. Okay, The Spy Who Shagged Me. Very good. All right. So with that, seeing as this is the we know where we are today, let's go.
Let's do
and
one more.
A Google search on Linus.
All right.
Now this one ought to be really easy, right?
Sure. Come on.
It's live, folks. Ha-ha! Trapped you. You thought. Okay, thanks a lot. Okay, of course, those of you know that Linus was actually named after Linus Pauling. Okay. So with that, now let's take a look at another example, and this time something that's a little bit more close to the operating system. And I'm going to ask Mandrake. Hey, he's already on stage. Mandrake from VA. Hey, Mandrake, how's it going?
How you doing?
Great. Now you've got some rather interesting stuff here with Enlightenment. So maybe you could give us a description of what you got.
Oh, well, what we've got running here is a multi-headed system running X386 3.9, which was just released last week. One of the things that's really neat about this is we can have more than one monitor. We can have as many monitors as we can have video cards in the machine. So we can have, we can set up as wide a desktop or as tall a desktop as we want to. And that's really great for me, at least, because I don't know about you, but I always have a ton of applications running on my desktop. I've always got Netscape open and some files open and a shell open and some graphics I got to look at and some servers I got to monitor. And then, of course, I got to have something pretty to look at, too.
I've got a sneaking feeling that you may use more computing power than I do.
Well, I might do that.
Yeah.
But like I said, gives you this really, with multi-head, it gives you this really great opportunity to expand your desktop over several different screens and have a single logical display. So as you see, I've got windows split across all the screens there. So I can take and move one window, move it between one desktop, another desktop. It moves between monitors seamlessly. So basically, it's fairly new. It's this new technology, but it allows me to have as big or as wide a desktop as I want to. Now, of course, not a lot of people have the luxury I do of having.
Yeah, you've got two extremely nice-looking flat panel monitors there, and I think not many of us can afford that.
Not everyone can afford these big 21-inch flat screen monitors. So for those of us who can afford big 21-inch flat screen monitors, you can have several desktops also. So say I have a second workstation or a second works desktop setup that I want to have. I can have multiple virtual desktops, just like I can have multiple physical desktops also. So I have one desktop set up here, I have one desktop set up here, and I can do all sorts of other things on this one. So
that's great. All right. Well, thank you very much. Now, how can people find out more about this?
Well, if you want to find out a little bit more about this stuff, you can go to X386 at www.x386.org. Or if you want to find out more about Enlightenment, the window manager that you saw, you can go to www.enlightenment.org. Or if you want, you can come see one of us at the VA booth in a little bit.
All right. Now, somebody said that we have to keep talking about GNU, and every time we finished a demo, we had to throw one of these into the audience, right? So I forgot that one over there. So these are really, really good Frisbees. Woo! Okay. Thank you very much.
Thank you.
All right, so I can't resist to do one more demonstration on the user interface. And we just kind of had to sneak this one in somewhere because it's such a fun one. So, Randy, maybe we could bring this thing up now.
Yeah.
If you are of a certain age or if you have kids of a certain age, you're kind of consumed with MP3 fever, right?
Definitely.
And MP3 chaos. So tell us what you got here.
Okay, well, what we have here is what's called the Globecom Jukebox, and it's a front end for a bunch of free software that you can find out on the net, assemble it on your Linux system, and then run this as your web front end to it. And just like any jukebox would, you could pick a song and just have it play.
And that's Blur. We got the rights to that one because it was in the last Pentium advert. And it's a British band, so it's okay.
So anyway, but what's really kind of nice is that you can use this to manage your own music. So if you, for instance, if you have your own music CD, you can walk over to your CD drive, put it in.
Just hold a sec. So sure. Obviously what people do now is everyone's got zillions and zillions of CDs. And so you build an MP3 jukebox, totally legally, with your own copies of your CDs. Trouble is, maybe you've got 50, 100, 200 CDs. You can't sit there typing in the title of every track, and there's no way that the PC knows the title for every track.
Right. So what this can do is when we place the CD in here and we try and add the disc, the computer will go out on the internet to a website called cddb.com, and using information from the audio CD, it will bring up the artist name and the song titles for every song, so it's simply you just click on the songs you want to use,
right,
and then go.
I think this is one of the slickest integrated databases and applications I've seen. Saves you an enormous amount of time. Thanks very much. Okay, so those are some examples of different things that are being done with the user interface and the browser in order to make sense of all that information. The third area of problems I'd like to look at is in the area of instant response. Now, the internet is by structure a very burst-driven environment. And the communications industry has been used to this all through the last 100-odd years because the telephone system was built around a 24-hour cycle of usage all over the world. The switching structure was put in place to handle these swings. But the internet is far, far worse than that. It's complicated by two additional factors. One, the marketing campaigns or programs that produce surges, the radio campaigns, the TV ads, and so on, that produce a big hit. And secondly, on top of that, you then have rich media. For example, the impact of the next World Cup, when a soccer World Cup in the evening, half the planet, or anyone who has a PC, will want to go and look at streaming video of the goals that get scored. And you have these huge spikes in demand. A CIO of one of the largest banks in America was telling me recently about the worries they have on the millennium, 5 or 10 minutes after midnight. Going up to midnight, nobody will have been accessing the net. After, everyone will think about, the millennium bug. Everyone will try and access their bank accounts to see if their money is still there. And you're going to get this huge spike. So we need to build an infrastructure that can handle these incredible swings in access. So what I'd like to do now is I'd like to look at some cluster scalability and performance. And I'd like to look at a little demo here and call up John from VA. And as we've got two machines coming out, you can guess we're going to have a bake-off. So what have we got here, John?
These are two machines. One is a 36 node or 36 SMP box, and the other one is 19. And we're going to render a power image, and we're going to illustrate how you can do processes in parallel to save time.
Okay, so basically this is a demonstration of cluster scalability. We've got 18 nodes with 2 processors per node on here.
Correct.
And we've got
9 nodes with SMP 9 nodes, 2 processors each.
Okay, well it sounds like it's going to be a fairly simple thing here.
Yeah, you're going to win or lose. Do you want to lose?
I'm going to win or lose, do I want to lose? That is an incredibly existential question. You know, I really want to lose.
After you.
Okay, so I'm going to go over here and lose. And you're going to give me the simple idiot's guide instructions.
So all we have to do is do 1, 2, 3, then go.
Yeah, okay.
1, 2, 3.
I jumped the gun. I'm a real loser. I went on 2. But don't think it makes much difference. This is a standard, very high compute-intensive rendering demo.
Correct. It's a high CPU-intensive task, and that's why we try and put it across as many nodes as possible, as many processors as possible at a single time.
And how scalable do you think this is?
This application itself is very scalable. It depends on the architecture you put it across because you are passing information across a network. In this case, it's gigabit. But it should scale pretty linearly to about 64 nodes.
Okay. All right. Well, thank you very much indeed.
You're welcome.
Thanks.
Good day.
Okay. So once again, hey, John, if people want more information on this?
Yeah, go to VA Linux's booth, and we have more information. And also on the net, there's information about the parallelism.
Okay, thanks a lot. Okay, so we're going to come back to performance a little bit later on. We've got one last demonstration left on performance. But I want to now move on to the last of these categories of problems, which is total reliability. And again, the challenge that the internet presents to us is much, much more deep than in the past. In some ways, we've been on this kind of constant ratcheting up of requirement going back over the last few years. In the 1960s, when people ran enterprise applications, 95% to 99% was kind of okay. That has got ratcheted up and up and up. And now the demand for the server infrastructure on the internet is kind of really 5 nines. 5 nines, as you probably know, is something like 5 minutes downtime per year. And there are lots of people who are also saying, no, we actually need to go to 6 nines to match the telephone reliability. Now, 6 nines is down at something like 30 seconds. 30 seconds, I guess you could say it might be long enough for a reboot if you had some super quick reboot, but it wouldn't be enough to cycle through the memory test on a typical large server with half a gig or a gig of memory. So that really, really is a challenge. What I'd like to do now is to call up San, who's going to look at the VA Cluster Manager and some of the stuff that, the code that's being embedded there for reliability. Good to see you, San.
How you doing?
Okay, so what have you got here?
What I've got here right now is VA's new VACM cluster management software. We released it to the open source community actually today. It's available off of VA's website. What it basically does is combined with Intel's Intelligent Platform Management Interface, which is available on all of their server motherboards.
That's IPMI, a really easy to remember acronym, right?
Yep. It's your company.
Yeah. Guilty as charged.
Basically, what it allows you to do is to affect a lot of low-level control and monitoring functions that you weren't historically able to do on PCs, such as powering a node off, powering it on, hardware reset, all completely remote. Perhaps one of the more interesting features is actually the ability to actually get a remote console BIOS redirection. So over the network, you can affect changes to your entire BIOS.
Right, okay. So supposing you were the systems administrator on a big ISP with a diverse series of clusters, give us an example of how you go about managing that.
Okay, well once the VACM software is actually installed properly, all an administrator need do is scan his network for a VACM server. That's synonymous with basically the cluster controller. As you can see, we've already found one, which is our little rack over here. Once the scan is complete, I can bring up that node. I'll just drag it from over here. And what you see is a list of all the individual nodes that are being controlled by that cluster. Once you've connected, what you can basically do is bring up for any node, bring up a status display, which would tell you a number of things at the low hardware level. The least of which is the power status of the machine. Is it on? Is it off? The intrusion status. Has anyone been inside the case that shouldn't have been inside the case? And the fan status. Are the fans running? Is everything okay? You can also affect in singular node and group operations, such as turning the entire node off, the entire cluster off, which I'll do now.
Okay, well, 1 second. Let me go over here so I can just check it is going off. Okay, so here's the smaller of the two clusters. Bang. Yep, and it's gone all quiet and it's gone off. And I guess you can switch that back on again. Yep, and it's come back on again. Great, all right. Well, I could probably throw a problem at you by pulling out one of these cables here.
Well, not a problem at all. Once VACM detects the loss of contact with IPMI, it'll throw up an alert. Once the alert, and there it is. And basically at that time, I would give you a call and probably yell at you and ask you to please plug it back in. Once you had plugged it back in, I would be able to determine, after talking with IPMI, that the fault was caused by a loss of AC power.
Okay, so how would you say this is different to other types of doing network management?
Well, normal network management software relies on a type of software to be actually running on the node that's being monitored. With IPMI and VACM, It's completely unobtrusive to the local CPU at all. You don't have to run anything on the target node, nothing at all. The other thing is that these software-based management server, client-server systems that have been historically available don't give you the ability to affect a lot of low-level hardware-type things like the power down, power up, and reset without resorting to arcane and expensive solutions like network addressable power supplies and that type of stuff.
So driving it through the hardware, it means you get access to the BIOS information and so on in the boot sequence.
That as well. In fact, that's perhaps one of the more interesting things to people who are interested in colo is that remote BIOS features. There's virtually nothing that you can do at the physical console of a machine that you cannot do remote with IPMI and VACM.
Okay, well, there's obviously a lot of work has gone into this. Now, you've got a birds of a feather session later on, right?
Yes, we've got a room that holds about 150 people, and to find out the time and day of that, or the time and place for that, just come to the VA booth.
Okay, and if people can't get into the room, then they can hit the net and get some more information, right?
They can get more information off the VA website, or I will be in the booth giving detailed demos, something a bit more intimate.
Okay, brilliant, great. Now, you told me VA's got some kind of really weird handshake, right?
Yeah.
So you got to go, boom. Okay, got it.
He's not bad. He's not bad.
Thank you. I'm really worried doing that in case I miss his hand and hit him somewhere else. But then he's Canadian and I'm British, so we'd probably get away with it. Okay. So I said that we hadn't quite finished with the performance demonstrations. And we've used nearly all of our game show style doors. We've got one demonstration left. Should I go for the left door or the right door? Right door, okay. We've got a bunch of right-wing people in the room here. Come out, whoever you are. Come on out the front here.
Instant availability.
Okay, for those of you that don't recognize him, this is Andy Grove, who's the chairman of Intel, and you must have just been wandering by.
I have been wandering by, listening to all kinds of buzzwords that I couldn't understand.
Okay.
But I'm here to tell you something.
Right.
All of this stuff is fueled by a very major change in the business environment. And that change has to do with transactions and business moving onto a new medium, a new way of doing things, electronic transaction, electronic connections, much along the lines of everything that you've demonstrated here. And I have some data here that suggests, that compares the American gross domestic product with the portion, the lower line is the portion of the US gross domestic product that's purportedly is on the internet today, done via e-commerce. When you look at 99, you can see that we are approximately 1% is a semi-log plot. You know about semi-log still?
Yeah, I think you told me that one.
One division is a tenfold change. So 2 divisions correspond to 1% of the US gross domestic product being done on the internet today. And it's suggested that in 3-4 years' time, we're going to close that gap to within 10%, to be 10% of the total gross domestic product being on the internet. Now, I have a lot of problem with these numbers, and you are the best witness that I have to bear me out, because that's 1% where we are today is $100 billion in the US, and how much will Intel do in 99 on e-commerce?
We'll do probably $15 to $18 billion.
Well, with all due respect,
we're not 15%, that's for sure.
We are not 15% of the US e-commerce. So that number is, if anything, is understated. And what that trend, however, suggests, even whether it's real or whether it's understated, is an enormous prospective demand for servers. And when you compare the installed base of servers today, which is on the left bar, with and scale it kind of by the seat of our pants, but adjusting it with the growing demand for the internet in different parts of the world, with different people getting on the internet, looking at the increasing use of diverse services, some of which you've demonstrated today, but it's only a little portion of it that you've demonstrated today, particularly when you consider the amount of innovation that's taking place on internet applications, looking at the increasingly rich use of data and availability of data on the internet. And lastly, consider that some slack has to be built into the system, because as the dependence on electronic services is going to skyrocket, users' tolerance for downtime is going to decrease, and the only way, or one of the ways, that suppliers of electronic information will have to do to defend themselves from that is to build in some slack. What all this works out to be is the right bar of server demand, which suggests that something like 95% of the servers that we will need by 2005 are still yet to be deployed. And as you know, we are working very hard to develop a next generation product that is meant to fill this role extremely well. That's the IA64 generation that is likely to do the same improvement in performance and capability as the 386 did when you were programming Unix onto 286. And we think of it as the future engine for e-commerce. And I think it is a wonderful opportunity for us to give a little bit of a brief update on that. The first instantiation of the IA64 architecture, the Mehat processor, is in the fab, which will yield some silicon in a few weeks' time, and we'll either know that it works or it doesn't work. But in the meanwhile, we have developed some very sophisticated simulators for this architecture, and we have booted 8 operating systems on this processor, one of which is Linux. And this processor has some features that is going to be extremely significant for e-commerce application. Of course, the 64-bit addressability will enable people to store large amounts of e-commerce data in memory. The EPIC architecture lends itself very well to transaction processing, and the outstanding floating point performance that was designed in this chip lends itself very well to data mining, getting out of the information overload that you talked about earlier. But I think it is perhaps time to demonstrate what Linux looks like on the IA64 architecture.
Okay, great. Well, I think the explicitly parallel features are going to be very, very interesting, tying in with the cluster demo that John gave earlier on. But what we have here is we have the Mehat simulator running on this system here. And the system is a dual Pentium 3, 550 megahertz. I'm sure you all have one of those in your home, right? With about half a gigabyte of memory. And we have the Mehat simulator, and running on top of the simulator, we have the Linux IA64 kernel running on top of it. So this is the first time we've ever shown that, and the work is a result of the Trillium team, which is SGI, HP, Cygnus, Intel, VA, who've been hosting it, and we're pleased to announce IBM.
Right.
IBM announced, I think, yesterday or this morning that they were also part of that effort. So we have here, plugged into the Mehat simulator, hopefully soon to be running on the silicon, we have IA Linux 64. Now, to test the Linux 64, we have loaded up probably one of the most common applications, which is Apache Web Server. So we have basically got here an IA64, Linux IA64 Apache Web Server, and we'll just generate a transaction across to it. This is the first time in public you've seen an IA64 web transaction, and there you are. Nothing magic about that, but it served up the transaction, and we've gone and done a hit, appropriately enough, on the Trillium page. So there you are.
Well, the only remaining thing that I want to bring into here is that our plans are with IA64, starting with Mehat and going beyond that, is to bring all the power of the PC economics to it. We will market it to the world's manufacturers of computers. We will proselytize it to the world's software manufacturers, and we hope to bring a very wide variety of choice that lends itself not only to varieties of applications, but to the economic power of this type of a horizontal business arrangement brings to the user. That is, continue on what you described earlier, the lowering cost of computing power, and continuing with the corresponding increase in power much the same way as we have done for the last 25 years.
Okay, well, thank you very much.
Well, there's only one thing left.
Correct.
There's a lot of people listening to what we're going to do, and some of them may be interested in participating in this
I bet a lot of people will be. Okay, so how do you get involved? The Trillion team is going to release the IA64 kernel source, open source, in Q1 of next year. Realistically, that will be a time when we've had to get a good look at the silicon and get it out there. So that source will be released. We will give access to a kind of network around the world of application solution centers that we are setting up, where you can go in and run your code and test your code if you want. More appropriately for the Linux community, we're also going to make this available, a series of Merced servers available hanging on the net in a number of obvious locations, SUSE, Turbo Linux, Caldera, Red Hat, and in VA. We'll put those servers in those places with the welcome support of those organizations and make the systems available across the net.
So people can actually do development of application development and tuning from their homes, from their offices, or from their employers' offices.
Yeah, obviously the Linux community knows how to exploit the internet for development incredibly well, so that makes the most sense for the way to go ahead with this.
That's good.
Okay.
One more item.
One final thing. Those of you who've got the entrepreneurial gleam in your eye, about a month ago we announced a venture capital fund called the IA64 Fund, which Intel announced with a whole bunch of other companies. And the idea of this is we've all put some money in a big pot, and the money will be invested in companies that have got really interesting new types of products that are going to run on IA64. And that money is a pretty substantial amount of money. And as of speaking, we've announced this thing, and more than 90% of the money is still available. So if you've got ideas for any really interesting products, or you want to go and do something really new and interesting on this architecture using EPIC, the explicitly parallel features inside of it, then please go along to intel64fund.com, or you can send your proposals to proposals@intel.com.
Okay, Sean. Can you finish this talk without me?
I think I could probably finish it without you, yeah.
Okay, let you
All right.
try.
Thanks
Bye-bye.
a bunch.
Bye.
Okay, so really, in summary, I think that the message here, born to be wired, the Linux community is absolutely born to be wired. We've had great fun over the last couple of years working together. The challenges over the next 2 to 3 years I really think will dwarf what we've seen, and I think we're going to have an incredible amount of fun. Thank you very much indeed.